The seventh question, a rigid closed container contains N1 moles of an ideal gas at temperature T1 Kelvin and pressure P1 Pascal. When an additional amount of the gas was inserted into the container, the new temperature and the pressure were T2 and P2 respectively. The total number of moles of the gas now in the container is. Right, there are two situations. Before addition the extra amount of the gas and after addition the extra amount of the gas. Let's mark those data in a diagram. Right, now this one will be the before situation, before addition of extra amount. This will be after addition of the extra amount. They haven't given the volume of the container. Let's assume it's as B. Since they have mentioned it's as a rigid container, the volume doesn't change. The number of moles initially will be N1. Let's say P, V, N, T here. Pressure is P1, volume is V, number of moles is N1, temperature is T1. Now after addition of, let's say, X amount has been added, so the new values P, V, N, T. The new pressure is P2, they have given it here. The volume doesn't change, it's same volume. The number of moles will be, let's say, N2. They haven't given that, we have to find the N2 value. The temperature is T2. Now we can construct a relationship between these two. Since it's an ideal gas, we can apply the ideal gas law. So by applying PV equals nRT for both gases, pressure is P1, volume is V, number of moles is N1, R T1. Now we can since they haven't given the volume as a data, so that's what we have introduced into the system, therefore we have to isolate that. So we can eliminate this volume term from the equation. So V equals N1 R T1 over P1. This will be our equation 1. Now let's substitute the data from the after situation to the PV equals nRT. The pressure will be P2, volume is the same, number of moles will be N2, that's what we want to find. R is R, temperature is T2. Now V is equal to N2RT2 divided by P2. This will be our equation 2. Now both of these expressions give the volume of the gas, so both of these are then equal. Right, let's make them equal. 1 equals 2. So N1 RT1 over P1 equals N2 RT2 over P2. Now this R gets cancelled off, and we can isolate N2 here. Therefore we will get N1 T1 P2. This P goes here, divided by, and this P1 goes there. No, we have to keep the P1 there. We have to take the T2 here, so it will be P1 T2. Okay, this is the answer. So N1 T1 P2 divided by P1 T2. N1 T1 P2 divided by T2 P1. Yes, T2 P1. The answer is the second answer. This one. Alright, let's go to the next question.